Now let's look at benzene reaction and alkyl benzene. So first of all, we will focus on reaction of benzene and, look at the left hand side first. Okay, so this is benzene. I purposely draw a hydrogen so that you know what is going on. Okay, so first of all, the process name is halogenation, but the mechanism or type of reaction is electrophilic aromatic substitution. This is the process name, halogenation. Okay, so we would look at what happens to the hydrogen. So the hydrogen is being substituted by chlorine. And remember, we use catalyst FeCl3, not UV, because this is not alkane. Okay, then next one, if we have NO2, so we need to use concentrated nitric acid, concentrated sulfuric acid, and it must be 55 degrees Celsius. Okay, another one, if you are given acyl chloride, for example, CH3COCl, so you just substitute the CO, break up the Cl. Okay, so what you can draw is like what I've shown here. Just break down the chlorine, break down the hydrogen, and then you combine. Or like what I've taught in the earlier video, what you can do is put the acyl chloride on the left hand side. Okay, so hydrogen, then take away the HCl, then you just combine both of them together. Okay, now we go to Friedel-Crafts alkylation first. Okay, for Friedel-Crafts alkylation, same thing. We have RCl, so we just break down the Cl and attach to it. Okay, then after that, alkyl benzene can react with UV. Okay, if you put UV, the substitution will occur at hydrogen. Okay, so the types of reaction is free radical substitution. It's not an electrophilic aromatic substitution. However, the process name is the same, that is halogenation. Okay, then we have another one that is oxidation. Okay, so for oxidation, because the benzylic carbon, the first carbon that attached to the benzene ring has at least one hydrogen, therefore it can become COOH. Okay, now you can see here that I have jot down some extra notes. Okay, this is for Friedel-Crafts alkylation. Okay, let's make it bigger before I've forgotten. Okay, if you have haloalkane, okay, so you have to look at the haloalkane. Label it primary, secondary, or tertiary first. Okay, especially the carbon that is attached to chlorine and also the second carbon that attached to the first carbon. Okay, so we have primary and secondary. When we have primary and secondary, remember, secondary is more stable, so it will undergo rearrangement. Thus, it will attach at the second carbon or the secondary carbon. Okay, if you attach it at the primary carbon, then your answer is incorrect because it is less stable. Okay, then another notes that I have jotted down is the tertiary alkyl benzene because it has no benzylic hydrogen. So there will be no oxidation going on, means there will be no benzoic acid will be formed. Okay, for example, if this one undergoes oxidation, it will become COOH. Although it has 3 carbon, it will still just become benzoic acid. So that's all for this part.